Hello everyone. Okay, if you were watching the last video in reference to this particular design here, this is just a continuation of this video that was made a few days ago in reference to this being an electric motor. These are coils, so this will continue the coils around. On the day I spoke of this last, I mentioned the idea, and I was trying to recall the experiment that I was studying, and then my thoughts about how this worked. Okay, and it was a theory, so I haven't seen this work, but it's a thought experiment, and it's an experiment that other experimenters were sharing their theories on. So I'm not sure I'm describing it correctly, but I'm sharing kind of like I'm trying to work through this in my mind about how this might work. It may not work. It may work. Wouldn't that be nice? Okay, so now what I want to add to this is I forgot an important detail. Now it could be tried this way, right? We could try. So this is the coils in a motor, right? And motors have many different configurations of windings. So for now, for the moment, we'll go ahead and continue the coils here. And I'm not sure I'm winding these correctly, but this is just to get an idea of motor coils here. Now there's an idea that this is a very interesting idea, which I don't spend a lot of time on, what I'm going to share with you right now. There's an idea that, okay, so we had Richard Feynman, Caltech, and also Nobel Prize winner, right? He was a teacher at Caltech. And then we have John Wheeler. I think he was a teacher at Princeton, if I recall correctly. These men were highly intelligent and completely dedicated to understanding, if I say, the molecular structure of energy and the universe. They both talked about there being enough energy in space, in a small area of space. And I'm talking about an area that is similar to this book here, right? This area here, similar to that. Or even less than that area, right? Being able to, the energy in that space, and I mean in that actual space, in the actual space that this notebook occupies, there's enough energy in that space, whether this notebook is in that space or whether it's not in that space, right? The same space, whether it's air there or no air. It could just be vacuum, nothing there. Okay, that energy's still there, it's always there. But if we have this here in that space, then we have the vacuum energy plus the material universe energy. Or if we have air in that space, we still have the material universe energy, which is air, right? Air is, I think of air as a material part of the material universe, right? Because it's not nothingness, it's not vacuum. But even the vacuum of space is hydrogen and helium, right? So it looks like we just have material universe everywhere, at least in the way that I'm thinking of it at this moment. So, but John Wheeler and Richard Feynman talked about energy being able to, I guess, power the world with that small amount of energy, vaporize all the Earth's oceans instantly. That's one way it could be used. We don't want to do that though, right? But just kind of giving visuals of how much energy there is, right? So, but then there's this idea that is a rare idea, according to my research and study. But sometimes someone will say, well, wouldn't it be nice if we could use that energy? We can't use it, someone might say, right? But wouldn't it be nice if we could? 100% of my research and study says that we are using the energy. We're interacting with the energy. And it powers our electric grid. It sustains the material universe. What I should say is I'm looking through the lens. I'm 100% looking through the lens, the perspective that we are using the energy. That might be a better way to say it. And I'm trying to understand the universe in accordance with the possibility that we are already using the energy, right? Okay. So it's not about proving anything, but it's about discovering possibilities of ways of seeing things together in collaboration, and to further clarify perceptions of understanding. So, if I say it that way. Okay, so let's continue our coils here. Okay, so we went all the way around. So now we have our electric motor, and then out here, this outer line, so that we'll call this the stator, right? Because that's where the coils are. It doesn't move. That part doesn't move in this configuration. This is like my scooters, the scooters I have, that the wheels have these motors here, right? And then this is the part that the magnets are on, this outer part, and then the tires out here, right? The tires out here. And so the outer part turns, right? The tires and the magnet move together, and then these provide, I don't know if it's sound waves, right? Gerard Morin talked about sound waves is what is making those magnets move away really quick. So Gerard Morin was teaching us that, and he had a theory that sound waves were what is coming through these coils being pulsed into the magnets. And you can hear this when you turn on an RC car and you hear that deet 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 deet. You hear that sound on a remote control car, like 10th scale, 8th scale, those different electric cars. When you turn on the speed control, it'll beep according to maybe how many cells the LiPo is, or there's different, the beeps, the configuration of beeps, length of beeps. It's like language, right? It's telling us information about the capacity of or the voltage of the batteries, or how many cells we have, things like that. So the beep, and then Gerard Morin said he opened up the motor and didn't see a speaker in there, so where's the sound coming from? And he said the sound was coming from the resonance of ringing the magnets at a resonant frequency from the coils, right, in the motors. So now my scooter motors don't make any noise, but I'm talking about the remote control cars because it's common with those. It's also interesting that remote control car, if we look at 1/8 scale remote control cars or 1/10 scale, there's a company called, I think it's called FMA, F like family, M like Michael, A like America. So FMA Direct, I think that's one of the words we can use to look this company up. And they have a charger called the Power Lab 8. Now that might be an older model now, there probably is much newer models, but they were charging batteries in 10 minutes or less many years ago. And we're talking about when it usually would take, maybe a half an hour, or it could even take an hour to charge a battery, or much longer than 10 minutes. And they were charging batteries in 10 minutes and the batteries weren't getting hot. And I think of gbatteries.com and what they're achieving now with not just small batteries, but also automobile batteries. So moving back to this idea here. Now, last time I explained this, I was talking about it just as a thought experiment, and I'm trying to recall what I was studying, because I've studied so many different ways so many different theories about the ways we can experiment and approach an experiment. I'm trying to recall the way I was thinking about this in the past, and I had mentioned connecting, so we have, okay, so this is the way I had read it before in the past. The way I exactly read it was, so let's move over here to this new area, right? What it was this idea of if we could add a coil between two coils, if we could add a coil, right, So let's say we added a coil. So here's the wire. Here's the wire here, right? So if we added a coil, now the coil would have to be down in here, right? It couldn't be way out here, right? But so I'm just going to draw it out here though for the drawing. So this is a coil here, and we'll say there's an iron core, right? So we'll say there's an iron core, and then there's a coil. Right, and then we connect a capacitor to that. So we connect the capacitor, right, a capacitor to this. And I'm not sure I'm connecting that capacitor correctly, but this is just, I'm just connecting this the way that I imagine it might be connected, but there could be a better way. And I don't even know I'm doing this right. So the idea was, if a motor had more space, we could add a coil between each coil. And each of the coils we add would have a capacitor on it. And then that capacitor, from that capacitor, I would connect it to a full wave bridge rectifier, if I recall correctly. And then from there, it would go to the battery. And then between each of these, I think these are sometimes called fingers or legs. I'm not sure if that's correct. I think I've read of that being stated this way. These iron cores here coming up, a finger or a leg. But I'm just going to call it iron cores, these iron cores with coils on them. Now between each of those, imagine the same setup here. And each will have its own full wave bridge rectifier. And then every negative from the full wave bridge rectifier would go to the battery negative, and every positive would go to the battery positive, okay? So if that could fit in there, right, but how would we do that? We'd have to make our own motor, right? So I think what happened is I skipped all this that I just explained to you, and I went right to this, because I was trying to think, how could I do it with a regular motor right now? Well, right now, motors are not necessarily wired the way that I ran this wire. Like I went from here to here to here to here, but motors tend to be wound very differently than that. So, and at the moment I cannot even recall even the different ways that I've seen. I know that there's very different, like this one might be connected to there, and this one might be connected down here, and then it could be like 3 over, like 1, 2, 3, like this one goes to here, and then this one goes over here, and this one, something like that. And you could check the different wiring configurations for motors yourself to confirm that. But the idea is, now I'm thinking, okay, if this theoretically worked, just in theory, right? If this could work between each of these, then I thought, could I take an existing motor and just put a capacitor between 2 existing coils? Now let's look at that. So here, the capacitor's connected. Like, how would that be different than this, right? If this works theoretically, I'm just going to say theoretically, if it worked, then I'm just thinking, why wouldn't this work? If this would work, right? So let me just finish this. This is a capacitor, just so we know what everything is here. So this is a capacitor. That's a capacitor right here, okay? I don't know if we would call that a quick recovery capacitor or what, but it would be one that could handle very, very high frequency very quickly, right? Because this is very high frequency here, right? What is this, 20,000 cycles per second? 100,000 cycles per second? I think Gerard Morton was saying he wants to see 100,000 cycles per second. He wants to see a very high cycles per second. I'm just remembering some of his videos because I've watched all of his videos hundreds of times. And do I recall everything? No, I don't. So, and every time I watch them, I think I'm learning something new. So it's very interesting to continue in this, when you study a subject, when I study a subject, how when I go back to something, it's just brand new again. And I think, how does that happen? So I'm going to start making videos about my thought process, because I should have been doing that from the beginning. And I always wanted to, but I always felt like I had to have things worked out before I shared them. I don't know where I got that idea from. It's like the idea of having to be perfect, right? No, we don't have to be perfect. We could strive for perfection, but as long as we know that we're not going to get there, or that we don't need to get there. Because what would perfection be? There'd be nothing to learn if we were already at perfection, right? So I don't want to be perfect. I want to always be learning. So, so if this theoretically worked, right? Now look what we have here. This is important too. So in this instance, this wire connects across, but I tapped into it at 2 different points. And I also don't know if that's correct. I think that's the way that I was reading the theory of how this could work. But I don't know what that actually does here. The word nodes keeps coming up. Node, right? A node. John Bedini talked about nodes, right? So if we have one wire, he would say you can connect to that one wire that's pulsing. If it's pulsing, if it's an impulse technology, and I could be saying this completely wrong, so please study this for yourself, okay? Consider my words as a catalyst, hopefully motivation to learn on your own. I'm just sharing my thoughts here. I'm trying to work this out in my imagination, right? I'm shaping it, sculpting it. It's like I'm trying to write a poem about mechanical engineering with poetry, right? This is poetry here. It's visual poetry, maybe we could think of it that way, right? So this is art. This is a creative idea, right? This is how I look at it. So John Bedini talked about nodes, N-O-D-E-S, if I recall correctly. And he said if you have a wire, and this is the way I recall it, I could be completely wrong in my description of this, so please again, confirm for yourself. But if you have one wire, right? One wire technology, impulse. If this wire is pulsing, a strong pulse, right? You know, just imagine, let me think of this for a second. Okay, so in this instance, let's imagine that I have one magnet here, and this is north. That's north, and this is south on that side, okay? So north is on the outside, south is on the inside, okay? And this is a wheel that spins, and it has a magnet glued to it. And that magnet passes a coil, right? So I'm going to draw the coil over here with an iron core. So I'm going to draw this. That's an iron core, which a magnet would stick to, right? And then I have the coil, right? Okay, the coil goes to a full wave bridge rectifier, which we'll call this the AC. So AC, I'm calling it AC, I'm just calling it that, because it's a pulse, it's pulsing, right? That's going to go in here. Now I'm going to come out, I'll just call it DC, because that's what a full wave bridge rectifier does, right? It gives us DC, but the pulse would still be there because we don't have a capacitor in here. So it's still going to be pulsing. It's going to pulse every time this, I think, leaves the area. Not when it comes into the area, but when it leaves it. Because when it comes into the area, I think what happens is, I think this coil pushes against those, I'm just going to call it gigawatts, right? Because Back to the Future, I think he called it gigawatts. But that could have just been a mispronunciation. And I think, and I've read that people think that he actually meant to say gigawatts, right? Instead of gigawatts. It's spelled the same, isn't it? Giga and gigawatts. So I'm gonna say, and that's 1 billion watts. But there's all the energy in the universe available at the tip of this pen. Why? Because all of space is interconnected simultaneously. That's why. So there's no lack of energy here. We are never at a shortage of energy whatsoever, right? And that's why so many people are frustrated with the ideas and concepts of artificial scarcity, because we have everything we need. We need only share it with one another. It begins by sharing the thought process so that we can learn to think together in collaboration, in a worldwide solution-oriented collaboration, kind of like a world community of creativity, right? To build ideas. Okay, so on the DC out, so one of these will be plus and one will be minus. So the minus, and I'm going to go around this wire, and here's the plus. Okay, let me think about this now. See, this is where I have to go back and study again, because we have two wires right now, right? Maybe I could use either of those, and that's what I would do. I would try each one. I would try each wire. So to begin, let's try the negative. So this is the negative wire. I'm going to connect it right here, okay? And that's a negative wire. And the positive, I'm going to send directly to a battery. Okay, so this is a plus and a minus. So the positive will go to the plus, and the minus is here, and then that's going to go, we'll say, over to the minus, okay? That just means I'm going over that line, okay? So now we could probably use either of these, but I'm going to begin by just using this one. Now, if I understand correctly, and I could be wrong about this, but this is the way I'm thinking of it. When I think of a node, N-O-D-E, what is that? A node. A node, in accordance with what I understood John Bedini to be describing, is when you have a line like this, right, a wire, the nodes kind of pop up like that. So if I connect to a wire in two different areas, like here and here, and I run that to another coil, I don't know if it has to have an iron core, but we'll say iron core. And I completely don't even know if I'm describing this correctly. So this wire is going to go into this coil and then come out. Oh, wait a second. Am I remembering something? When we come out of this, I could be completely wrong about this. This is so embarrassing. When we come out of this, let's say we're going to go into a full wave bridge rectifier again. And this is where the experimentation comes in, and just trying different things. So I'm going to call this going into AC. I'm going to call this AC again, even though it can't be, can it? Because that's DC coming out. But I'm going to send it into the full wave bridge rectifier. And I'm just saying AC here because that's where I'm going to connect these 2 points. And then out will be DC, which is, I'll say DC and DC. And I'll say plus and minus here and here. And then we're going to go, and the question is, can I charge another battery? Right, plus and minus. Yeah, I'm reversing the polarities, but anyway, that battery's just turned around. Okay, so this is my plus, right? And this is my minus. So this is my plus, so that's going to go to this plus. And this is my minus, so that's going to go over to the minus. Now, I don't know if I'm doing this correctly, but the idea is that when you have a pulsing, I think this is what's happening here. When you have a pulsing, you can keep duplicating the energy, and it can keep on being duplicated. I think that's the idea. Now, this may not be correct, and maybe only experimentation will allow me to fine-tune the sight of the correct way to arrange wires, capacitors, batteries, polarities, right? Polarities, polarities, pluses and minuses. Let's go back to this. Okay, so this is an interesting idea. Okay, so here, this is things I want to try. Anyway, I'm really happy to be able to share this with you because I've been thinking about this for a very long time. thousands and thousands and thousands of hours. And I thought, well, what if I draw it out and tried to explain it? And I never imagined that I could even explain to you what I just did. But this is kind of what's in my imagination. And I'm really happy that I was able to describe it to you, because this, I can look back at this and I can duplicate this myself and just see what it does. And maybe I can't charge a battery, but maybe I can run LEDs off of this, right? And I can see if it takes more energy from my battery to run LEDs and lights and stuff, lights and things like that. And if it does, okay, but if it doesn't take more energy and I'm running my lights, then maybe that's energy harvesting, right? Maybe this is all energy harvesting. How do we access the energy in the environment? We already are accessing it. Tom Bearden teaches us that our circuits short circuit themselves. And as I study more and more about what Tom Bearden was saying, it seems like he's saying that we don't have to short circuit our circuits, but rather we can allow the circuits to be more efficient by connecting them differently. So that may only reveal itself in the actual experiment itself. Wouldn't it be nice if this worked, though, right here, just as I showed you, and it worked perfectly as a range extender without end? Wouldn't that be wonderful? And that would be in harmony with the universe. Okay, everyone, have a great day. Bye.